Hello, grade 8. Are you fine? Today we are going to continue about the chemical reaction, the part 2. We take an idea about the word equation and how to transform the word equation to a simple equation, skeleton equation reaction. Now, let we speak about the conservation of mass in the chemical reaction. During a chemical reaction, atoms are neither created nor destroyed. This is the conservation of mass. Hydrogen and oxygen gas react to form water. Hydrogen and oxygen gas form water. Look at the mass. What is wrong with this equation above? Doesn't it appear that one oxygen atom went missing? Here we have two oxygen atoms, but in the product, we have one atom only. According to conservation of mass, the proper way to write this reaction is 2 hydrogen, 2H2, plus 1 O2 gives 2H2O. The red coefficient represents the number of molecules or the number of mole of each reactant or product. But in this case, we don't write 1. If we have no index or coefficient, the number of coefficient is 1. Not all properties are conserved during chemical reaction. The conserved one are the mass, the types of atoms, the number of each atom, while the part which is not conserved, the color, the physical state, solid, liquid, or gas, the volume, the number of moles of reactant or products. What are the types of chemical reaction? There are 5 basic types. Single replacement or displacement. For example, redox. Double replacement or displacement. Synthesis or combination, decomposition, and combustion. 1. The single replacement reaction. A single uncombined element replaces another element in an ionic compound. There are 2 reactants and 2 products. For example, zinc, Zn, Cu, and SO4. This is the Zn, and this is the compound Cu and SO4. Look at the reaction in the product. Zinc combines with sulfate and copper is alone. This is the single displacement or replacement reaction. For more details, single replacement reaction have the general form A plus BC gives AC plus B. Do all single replacement reaction actually occur? No, not necessarily. Examine the reaction. Zinc Zn plus CuSO4 gives ZnSO4 plus Cu. This reaction does occur. Now let's try Cu plus ZnSO4. There's no reaction. Conclusion. Zn, which is the zinc, will replace copper in solution, but not vice versa. How do we know which reaction will occur and which ones will not? We look at the activity series. Elements with higher activity replace elements with lower activity during a single replacement reaction, but not vice versa. This is the activity series for metals from highest to lowest, lithium, rubidium, K, etc. And from the highest activity to the lowest activity. Activity series for non-metals, fluorine, chlorine, bromine, and iodine. The most active between them is the fluorine. For metals and water, between metals and water, some metals have a higher activity than hydrogen and can replace it in a single replacement reaction. In these reactions, you may think of water, H2O, as H and OH. Na plus H2O, it gives NaOH plus H. 2Na, this is the real equation. 2Na plus 2H2O gives 2NaOH plus H2. The second part of, or the second type of chemical reaction is the double displacement or replacement reaction. Parts of two aqueous ionic compounds switch places to form two new compounds. There are two reactants and two products. For example, AgNO3 plus NaCl. They react together to give AgCl and NaNO3. Look at this figure. The general form of a double replacement reaction is AB plus CD. It gives AD plus CB. Just like single replacement reaction, not all double replacement reaction actually occur. We can experimentally attempt a DR reaction. The reaction occurs if a solid precipitate is produced, or a gas is produced, or water is produced. If none of the above are produced and both products are aqueous, then there is no reaction. Examples of the double replacement. Look at this example. A precipitate forming, which is PbR2. Here, formation of water, water forming acid-base neutralization, and here, formation of gas, CO2. How do you determine if one of the products of a double replacement reaction will be precipitate? Use the solubility rules. Soluble compounds. These compounds break down when put in water. Example, NaCl, it transforms into Na plus and Cl minus. We say that NaCl has dissolved, is soluble, it forms an aqueous solution. This is the end of our lesson today. Thank you for watching and see you in the other video. Goodbye.